Hello everyone, I am Mrs. C. Shanti Chellaya. I am going to take a topic on Gilbert multiplier cell and analog multiplier IC applications. In this lecture, we are going to discuss the next type of analog multiplier, which is a four-quadrant multiplier, Gilbert multiplier cell, following by analog multiplier IC configuration and its applications. Discuss the principle of Gilbert multiplier cell. It is a four-quadrant multiplier which uses differential transistor pair. It is widely used in mixers, modulators, and signal processing. It provides high linearity and balanced operation. It is a foundational analog circuit that multiplies two input signals to produce an output proportional to their product. It primarily serves as a heart of balanced frequency mixers and modulators in radio communications and as a versatile voltage controlled amplifier of emitter coupled transistor differential pairs. The upper differential pair acts as a swing state. The lower pair converts the voltage input into current. The output current is proportional to multiplication of the two input signal V1 and V2. The circuit diagram is shown, which is designed using six transistors, two emitter coupled pair which consists of four transistors and another emitter coupled pair in which the second voltage is given, which acts as the current source. A four-quadrant operation is achieved like the Gilbert cell allows both input voltages V1 and V2 to swing between positive and negative directions. It operates in the current domain, leveraging the logarithmic exponential relationship between BJT base emitter voltage VBE and collector current IC. This makes the cell highly temperature stable and inherently linear. Its differential topology cancels out many unwanted mixing products and distortions, resulting in a significant cleaner output signal. It consists of three differential amplifier stages that share a common source or a tail current. The differential transistor pairs are arranged symmetrically. The current steering technique it improves the linearity. The balance structure reduces the carrier feed through. It operates with bipolar junction transistors. The output V0 is given as IEE tan H V1 by 2 VT and tan H V2 by 2 VT, where V1 and V2 are the two input signals and VT is the temperature equivalent of the voltage. The bottom differential pair takes the first input signal and modulates the tail current of the entire signal. The top cross coupled pair is sit in series above the bottom pair. It accepts the second input signal and selectively route the currents to the output modes based on the polarity of the second input. Thus, it achieves the output voltage V0 proportional to the current IEE and the product of two input voltages V1 and V2. Now we are going to discuss the analog multiplier IC. It provides accurate analog multiplication with minimal external components. It is used for laboratory and industrial application. The analog multiplier IC is an electronic component that produces an output signal proportional to the mathematical product of two input signals. It is widely used in radio communications, industrial controls, and sensors, and it is essential for real-time signal processing, modulation, frequency doubling, and sampling. They work on the principle of four-quadrant multipliers, meaning both X and Y inputs given in the IC can be either positive or negative. V out is given as Vx into Vy by V reference, where V reference acts as the scaling constant. Internally, these ICs utilize a Gilbert cell architecture achieving four-quadrant multiplier. The IC number AD633 is low cost, four-quadrant multiplier manufactured by Analog Devices. It requires no external components for standard operation. It features high output impedance and is universally used in general purpose applications. As discussed earlier, AD633 analog multiplier IC, it is a low-cost four-quadrant analog multiplier, and output equation is given as P0 is equal to x1 minus x2 into y1 minus y2 divided by 10. The bandwidth is around 1 megahertz, and no external components are required exclusively. Even if it is required, it has a simple external connection. Now let us see application of analog multiplier. The first application is frequency doubler. What do you mean by frequency doubler? The output frequency should be double the input frequency. So V out is equal to Vm square by K into cos square omega t. So here the input signal Vi sin omega t is given at both the inputs of the analog multiplier and output is obtained. So output is equal to Vm sin omega t into E sin omega t into cos sin square omega t, which is nothing but Vm square by 2 plus Vm square by 2 cos omega t. So if you filter out the DC component, you will get output voltage proportional to the double frequency of the input signal. The operation at the frequency of this single sine wave is given into both the x and y input of the analog multiplier. So using trigonometric identity, V out is equal to V square by 2V reference into cos 2 omega t, which is the squaring operation of V out is equal to A sin square omega t by V reference. The output waveform consists of two parts. One is DC voltage, which is the average value Vm square by 2V reference, and an AC ripple that oscillates at exactly twice the frequency of the input signal. Hence, it acts the frequency doubler. So we have discussed the operation of analog multiplier as a Gilbert cell and analog multiplier IC. The other applications of analog multiplier IC are it acts as a squarer and for amplitude modulation and mixing, division and square rooting. These are all applicable. Thank you.